The internet is a global computer network that can connect computers anywhere in the world. Using the internet, two machines in, say, Brazil and Congo can speak just as easily as were they both in the UK. To be clear though, the internet is the infrastructure. It's the cables, wires and antennae that connect computers together, allowing traffic to flow between them, as well as the equipment that controls where that traffic goes and how. Often when people say the internet, they're actually talking about websites, or to be more precise, the World Wide Web. Websites aren't the internet. They're a way of presenting text, images and video in an interactive manner that's mainly accessed via the internet. But it's not the internet itself. And neither is the cloud for that matter. Cloud computing is getting a connected computer to do something like store an image or work something out, instead of doing it on your own device. But really, it's a marketing term more than anything else. Despite its name, the internet isn't one big network, but rather a group of networks, big and small, commercial and non-profit, but all heavily interconnected. And by traversing one or more of them, any two connected computers can talk. You can think about the internet as working like roads. Spanning the country are motorways. They form the backbone and are high speed and high capacity. Off these, smaller A roads connect motorways to the towns and cities. They're still quite fast and carry a lot of traffic, but not quite as much as the motorways. And within the towns and cities are the normal roads. Comparatively they're quite slow, but they're also just for getting to your house, not for crossing the country. But whatever road you're on, the idea is the same. An interconnected series of routes that get traffic from any connected point to any other connected point. The internet proper is arguably the motorways in this analogy, the backbone routes. And just like an actual motorway, to use the internet backbone, traffic also needs to get to it. So what are the internet's normal roads and carriageways? At home, you likely have a router. This is a device that maintains local networks, like your home network, connects it to other networks, and routes traffic from devices to destinations, be that another device on the same network or one further afield. Crucially, when it comes to further afield, your home router is your gateway to the internet, as it links to the last mile, or local loop. The last mile is the physical infrastructure, cables and otherwise, that connects your home to a local networking hub your ISP is also connected to. Literally, it's the last mile between the two of you. And if you've ever wondered where that cable running from your router into your wall leads to, it's this, directly plugging your home router into the last mile. When you buy a broadband package, the type of broadband is literally the type of last mile you have. The type of infrastructure that's used to transport traffic from your home network to the local network hub. DSL uses the telephone network, Pure Fibre uses fibre optic lines, and in both cases they go to your local telephone exchange. You may also have a combination of the two, where your home is linked with copper wires to a street cabinet where fibre takes over. Most likely this is fibre to the X, which just denotes which bit is fibre and which bit is copper, with pure fibre being no copper at all. There's also cable broadband or hybrid fibre coaxial, which uses the same lines as cable TV. The difference with DSL is the type of copper cable and how information is sent down the line. It also goes to a television head end and not an exchange. The vast majority of last miles use physical cables, but especially in remote areas that's not always practical. Satellite broadband is where the last mile broadcasts a signal to a satellite, which relays it to a ground station or via other satellites until one is in range. Wireless broadband also exists. This is how your phone connects to the internet, and in a similar manner, your phone's antenna broadcasts a radio signal to a base station. You may have also heard of wireless meshes, or projects involving balloons. These work along similar lines. A mesh network is where you have lots of wireless base stations with overlapping broadcast ranges, the idea being there's no blind spots. As for the balloons, they're something of a cross between wireless and satellite. The balloons broadcast large hotspots onto the ground which relay any traffic back to a base station, or between themselves until one is in range. The point here is, whatever the medium, you're trying to get traffic from your home to a place where your ISP has a point of presence. Speaking of transmission mediums, if you've ever heard the term modem, this is what allows your home router to transmit down the last mile. While very useful for CPUs, the way computers internally represent bits with electrical pulses doesn't work hugely well outside of small-scale controlled environments. Modems change this representation. They change the modulation of the signal. The same sequences of bits are still being sent, but now with an analog signal instead of a digital one. The reason for doing this is that analog signals, when sent down a DSL or HFC line, are more resilient to interference and signal degradation, which is somewhat unavoidable when last miles can be kilometres in length and exposed to the elements. It's not just phone lines either. Satellite broadband uses its own modems to translate the bits into microwaves, and arguably the optical network terminals that plug into pure fibre lines are just modems but for light. Last miles are not normally considered part of an ISP's network because their role is to connect consumers to hubs rather than providing high-speed data transport. In fact, the last mile you're using might not even be owned by your ISP at all. In most countries, the majority of telecommunications infrastructure is owned by a single company. Usually this is the national, and possibly formerly public-owned entity that installed it all in the first place. In the United Kingdom, this is British Telecom, or BT. And like its peers in other countries, BT is subject to local loop unbundling regulation, which requires it to rent out last-mile infrastructure to competitors, which it does through a subsidiary called Openreach. This is why when you switch your ISP, they'll just send you a new router instead of drilling a new hole in your wall. Amazingly, even satellite and wireless last miles might not be owned by your ISP. While this infrastructure isn't subject to unbundling laws, it's still quite common for smaller ISPs to rent wholesale network access, that is, the use of base stations and even the use of satellites from larger ISPs. Enough about last miles. Your traffic's at your local network hub. What happens now? Upon arrival, traffic is transferred to an access node owned by your ISP that's specific to your broadband type. Access nodes combine traffic from all the local last mile connections via a process called multiplexing and send it off to your ISP's network. They may also do some pre-flight checks, like ensuring you're an actual customer so as to not waste bandwidth. If you've ever wondered why ISPs send you a new router when you change provider, it's in part because it contains the authentication details for these access nodes. Now it's onwards to the backhaul, or the middle mile, which is a high-speed fibre link to your ISP's network. Here it'll be received by a border network gateway. This is the device the access node speaks to when doing the housekeeping. If satisfied, the BNG will pass your traffic onto a core router. These are monster versions of what's in your hallway or cabinet, and they shepherd traffic from all over the region, be it simply passing by or headed specifically for that router. ISP networks are composed of these core routers, connected via fibre optic lines which run over pylons, underground or under the sea. While the latter especially might sound very grand, it's important to remember those undersea cables are really just that, cables that connect one router to another. Granted, monster routers on either side of the planet connected with a cable many miles in length, but the basic principles are the same as what's going on in your home. Live field traffic is now a matter of being relayed from one core router to another until it gets to its destination. If the destination network has a different ISP, your traffic will cross over to their network at some stage. But in the eyes of the traffic, it won't notice anything, just a sea of places to go and routes between them. And once it arrives at its destination router, well, the whole process of backhauling the last miles happens again, just in reverse. Going back to the roads analogy, to drive across the country you need to use a motorway, but your house isn't connected to a motorway, so you drive upstream on progressively larger and faster roads till you get there. Of course, the motorway isn't one road per se, but a collection of interlinked roads, so you'll likely jump from one to another until you get close to the town you're aiming for, at which point you will do it all backwards, eventually ending at your destination. How far your ISP can take your traffic is described by what tier it belongs to. ISPs are classified into one of three tiers that roughly correspond to their size and reach. While there's no standardised definition, it's generally accepted that an ISP's tier is determined by the terms on which it sends traffic to other ISPs, whether it can do it for free or whether it has to pay for the privilege, respectively known as peering and transit. Peering is free and happens between two networks that consider each other comparable in terms of size, reach, and how much traffic they'll exchange. Peering networks don't charge each other. Instead, they both swallow the integration costs because there's mutual benefits in joining forces. Among other things, these include traffic being able to take more efficient routes, and that the combined network is more resilient should part of it suddenly go offline. Transit, on the other hand, is not free. Typically, transit is where smaller networks pay larger networks to send them their traffic. Smaller networks pay larger networks because while they are the main feeders that connect to customers, they consume a lot more bandwidth than they contribute. They also typically rent the infrastructure on which they depend. Indeed, along with renting last miles and backhaul infrastructure, a smaller ISP could in principle be renting its entire network, and therefore wouldn't have the costs of operating and maintaining it, leaving a larger ISP to pick up the bill. But where do the tiers fit in? Tier 3s are small networks. They're focused on end consumers, small to medium businesses, and their own networks cover a specific region like a county, state, or rural area. They pay Tier 2s for transit and usually don't peer with each other. Tier 2s are middle to large network, which cover big regions and sometimes entire countries. They'll peer with other Tier 2s and pay Tier 1s for transit to other regions, especially if they need to go abroad. Tier 1s are the biggest. Their networks are international and span continents. When you hear about undersea cables, Tier 1s are the ISPs that own and operate them. Tier 1s only peer with each other and they don't pay anyone for transit. Some Tier 2s are also considered regional Tier 1s, as they act like a Tier 1 within their own locality, but still pay for transit. BT is a good example of this. It's a Tier 1 in the UK and continental Europe, but it still pays for transit to other regions. It's worth saying, Tier 1s and 2s also supply end consumers, frequently providing businesses with private last mile connections, as well as regular internet to individuals. Whatever their tier, ISP networks do need to talk to each other at some point. Many ISPs will have what's called dark fibre connections, where they peer or transit directly with each other. But most of the peering and transit happens at Internet Exchange Points, or IXPs. IXPs are locations where lots of ISPs install equipment to exchange traffic between their networks. When businesses get private last miles, sometimes called direct internet access or Tier 1 lines, they actually often go directly to the exchange, as do the landing stations for undersea cabling, ground stations for satellites, and the base stations for wireless broadband. IXPs are run by a variety of groups spanning the public and private sector, but chiefly member-based non-profit organisations. Most of the world's 600 or so IXPs host around 100 carriers, but the largest are huge. The London, Frankfurt and Amsterdam internet exchanges all host around 1,000 ISPs, shifting colossal amounts of data between them. One Wilshire in Los Angeles, meanwhile, handles a third of the traffic between the USA and Asia. Now, even at light speed, sending traffic from one side of the world to the other takes time. So impressive as all this international networking is, it's much more common for your traffic to stay local. Voice chats across continents will have to make the trip. But if you're streaming the latest rom-com, your destination server is likely just down the road. The term for this is a Content Delivery Network, or CDN, literally a network of cables and replicated servers dedicated to serving you content as soon as possible. CDNs aren't part of the public internet, but the tech giants that run them are effectively acting as their own ISPs when they do. They lay their own fibre optic lines and they connect them directly into IXPs, and you'd be surprised how much of your traffic ends up flowing through one. In summary, the internet is a group of interconnected computer networks. It exists to transport information from one computer to another, wherever they are in the world. Your ISP operates one of these constituent networks, running the core routers that move traffic around, arranging connections between its network and other ISPs' networks, and either building or renting last mile and backhaul infrastructure to get your traffic from your device onto its network and onto the rest of the public internet. The last mile is described by the type of broadband you have, be it fibre optic lines and telephone networks, or even satellites and balloons. The last mile's job is to get traffic from your home to your local network hub, where it's sent on to your ISP's network. And once at your ISP's network, your traffic can be said to be on the internet backbone, or maybe just a internet backbone. There's ISPs and there's ISPs, and each one belongs to a tier that roughly indicates how big its networks are. But size isn't everything. The real test is how far your ISP can take your traffic before it has to pay to use someone else's network. The Tier 1s don't pay at all, the Tier 2s sometimes do, and the Tier 3s always do. Pay or not, ISP networks have to link up at some point. The internet is a group of interconnected networks after all. Some ISPs privately link via dark fibre, direct connections ISP to ISP, But everyone exchanges traffic at internet exchange points, which are locations where lots of ISPs install equipment to swap traffic between their networks. Now, while having an ISP with a continent-spanning network is pretty cool, your traffic may well not need it. The reason being that there's probably a CDN with a replica of whatever it is you're after just around the corner, relatively speaking that is. And that's incredibly important. With all those seconds you've saved not waiting for cat videos to buffer, you could do something productive, like queuing up another cat video,